Hello. My today's speech is about using LINSTOR on Talos Linux and how we build robust base for Cozystack. I'm going to start to share that I'm working with LINSTOR for a long time. I started as cloud engineer at Vedas. We had experience of running 800 nodes with LINSTOR, and I don't remember some thousands of DRBD devices. Later, I switched to work for Pelark. We were developing a Kubernetes platform and also get LINSTOR as component there. And since 2023, I founded new company for developing Cozystack. Actually, that's our main product. The main idea of Cozystack, let me describe it that way, that it allows you to transfer to all of your bare metal servers to being intelligent system for ordering managed services. For now, we are thinking that virtual machines, just pure virtual machines, are not only the way, and people are usually looking for managed services, like actually cloud services, databases, Kubernetes as a service, and things like so. So our platform actually providing such opportunity. This is how it looks like. So you can click and install some applications like Postgres, Kubernetes clusters, and things like so. Every application actually is just YAML file which you put into Kubernetes like API, and it just get deploys, have a full lifecycle management and working. So platform totally based on Kubernetes and backed by Talos Linux. So let's see the layers which we cover. So we start covering infrastructure needs, starting from the basic layer of operating system and hardware. Actually, Talos Linux provides us opportunity to hard code Linux kernel version and also all the kernel modules. Actually, Talos Linux is just the thing. We can say this is Linux kernel with modules and few binaries to run Kubernetes. There is no even shell inside. Then we deliver the layer 4. So we have storage based on LINSTOR. We have networking based on OVN. And we also have virtualization based on KubeVirt. The layer 3 contains operators, cluster API, and monitoring stack. And finally, on the layer 4, or we can say user layer, users have a nice API where they can order managed databases, virtual machines, and managed Kubernetes service. So the layer 1 done using Talos Linux, the whole platform managed itself using FluxCD and operators. And finally, it provides Kubernetes-like API for ordering those services. So today I'm going to show you how our experience, how we use LINSTOR on Talos Linux and how we consume it for every type of service. Let's talk about the Talos Linux first. Our main market is bare metal. That's slightly more difficult thing to manage than just pure virtual machines because you always need to manage firmwares, kernel modules. I had experience developing platform for various platforms like operating systems, Ubuntu, CentOS, and supporting all of this is make it really difficult. So in our case, we just hard-coded all the modules in Talos Linux image. And then you have to think about how to boot Talos Linux image on the nodes, how to provide the choice for disks and interfaces, because every bare metal server different. So main idea that we pre-built Talos Linux image with all the components we need, with all the kernel modules, and ship it as part of platform release. If you want to build your own Talos Linux, you can use factory talos.dev, where you can tick all the components you need. Or you can use Docker for building Talos Linux image. You can just specify this kind of YAML file, where you just specify all the needed firmwares and, of course, our favorite modules. So we usually use DRBD and ZFS for the storage. You can see that there, the final image which will be built will contain those modules by default. And then let's talk about how can we bootstrap this image to the servers. This is also interesting because we want to provide easy way for installing the platform, because again, every server is different. So We really like to do PXE bootstrapping. In this way, we just provide 2 Docker images with DHCP and PXE server. It can be temporary. The main idea that you can distribute image from those PXE server, from those servers to the physical machines. And then you use interactive script to configure those nodes and create Kubernetes cluster. If you want to try, this is easiest way to try. We have other installation method which is more declarative, but I like this one because it looks like old school Debian installer. So you can choose the node, put host name, choose the disk, enter some network details, and click next, next, next. It will generate Talos configuration with all needed configuration, including DRBD module loading and network interfaces, things like so. And finally, you can get ready cluster just in 5 minutes. On bare metal, it will take a bit more, I think, time. And we will see that those nodes are running exactly the image we prepared for our platform. This is actually a stable base for our platform, so we can have this layer 1. We can rely on it. We can always be sure that there is no some kind of DKMS dynamic system for building kernel modules. No, we just ship this image and start using it as is. So the REST components, they can be just consume this ready Kubernetes stack with modules and things like so. Let's talk about how we ship the REST components of our platform. The main idea that we just allow users to run one manifest, to apply one manifest to Kubernetes, and it will create container with Helm charts. Then FluxCD installed inside of this cluster will distribute all the components like LINSTOR, virtualization, KubeVirt, monitoring into the cluster. So if we want to update the platform itself, we just create new container with new Helm charts and new components. And then it just delivers all the components using FluxCD. This way we deliver LINSTOR. LINSTOR we use in different ways because we allow to run databases as a service. Usually we create clusters. In case of virtual machines, we also need to have storage-based replication. But for databases, we don't need to have storage-based replication. So we use LINSTOR in 2 ways: for provisioning local volumes without DRBD replication and to provision replicated volumes for user data. This way, we also deliver network fabric based on OVN and Cilium. This is main case for main technology for virtualization and running virtual machines in Kubernetes. Same way, monitoring stack and of course, virtualization. Those are tests. So before we choose some technology, we usually make some performance testing. And from my experience, LINSTOR can be 6-7 times faster in case if you compare it with Ceph because of various things, dirty locality and things like so. Also, what is more important, it does not consume as much RAM as Ceph. Actually, you can see that it is usually 11 times less. I think for now it might be even less. Okay, and now let's talk about the application deployment, how it works. So in our platform, we allow to bootstrap managed Kubernetes clusters, databases, and virtual machines. And I want to show how exactly it works. Let's see, for example, we have dashboard, and every tile on this dashboard actually Helm chart. But we don't use Helm charts for delivering end user components like pods. Actually, they deliver configuration for operators, but Helm charts are a good way for describing your application. So you can easily extend all the platform by adding your own manifests, your own Helm charts. But we use it as interface for describing this API. And finally, they transcoded transparently to Kubernetes API objects. So we wrote our own API server, which transcodes all of these Helm charts into normal Kubernetes objects. And now let's talk about managed databases. So we manage databases using operators because only operators provide you this full lifecycle management. We allow to create databases, manage users, configure automatic backups, and monitor, and so on. For this, we use normal Kubernetes operators. We just adopt them, just other components in our platform, and they're managing deployment of the application. Let's see, for example, if we order Redis service. So we have this Helm chart, which deploys few YAMLs, which are then managed by operator. In dashboard, you have unified interface for configuring, and of course, you can also use API with small amount of parameters. Finally, it just creates free. Finally, it just creates free YAML objects like Redis failover for Redis operator, service for accessing, and scrape service for scraping metrics from it. That's it. Let's talk about the storage now. Let's have example that we have 3 nodes. We installed LINSTOR on them. We created storage pools, and then we let Postgres operator to create Postgres cluster. In this case, we always spawn multiple replicas, but we don't need to have replicated storage for them. They stores the data, like every replica stores have its own PVC, and they store the data right in this PVC, right in ZFS or LVM. What is more important, it's not running inside of virtual machine, so we have native performance of databases on bare metal. Yeah, and the Postgres itself replicates itself using Postgres mechanisms, and in this way we usually store just like local volumes. While virtual machines, let's see how it works in that way. Again, we have dashboard, create new virtual machine, and then it creates objects for KubeVirt for managing this virtual machine. We can't run virtual machine in multiple instances. For this reason, we want to be sure that user data will never be lost. So for virtual machine, it requests replicated volume. In this way, we can be sure that if node will go down, the virtual machine will be moved to another and will continue working with the same data as before. And we can live migrate it across the nodes thanks to LINSTOR and Piraeus compatibility for this. And now the most interesting stuff, how do we run managed Kubernetes service? We actually run Kubernetes inside of Kubernetes. But finally, it is the same Helm chart with pile of YAML files, which are then managed by Cluster API, KubeVirt infrastructure provisioner, and Kamaji. Kamaji is a tool which allows you to run Kubernetes API, just like pods in other Kubernetes. So we have reliable API, and we can configure cluster autoscaling to create worker virtual machines automatically. Also, we use FluxCD to deliver components. So we have 2 clusters. We have management Kubernetes cluster, which is installed on bare metal, and we have tenant Kubernetes clusters, actually Kubernetes clusters for every user. So we use FluxCD to deliver components on both of them. This is a list of the components we deploy for managed Kubernetes service. You can see that there is Cloud Controller Manager, Cluster Autoscaler, and of course CSI driver. If you want to have it to make it working with LINSTOR or any other storage provider, KubeVirt provides you their own CSI driver, which get installed into tenant Kubernetes cluster. This is how it works. So first, we create virtual machines. They can be created automatically by Autoscaler. And when a user create new pod, this pod can request the persistent volume. In this case, KubeVirt do the strange thing. Because pod spec is immutable, first it creates volume, and it also creates the second pod, which then delivers this volume to the worker node. And then KubeVirt CSI driver can actually access it and use it as normal SCSI device. In case if you shut down the pod, it will also remove hot plug volume, not hot plug volume, hot plug pod. And you can run it in other node, and then new hot plug volume pod will be created for attaching this volume right from LINSTOR of management cluster into SCSI device of tenant cluster. That's actually how it works. This allows us to provide truly managed Kubernetes service, not just Kubernetes running in virtual machines deployed by Kubespray. No, we have fully managed lifecycle of Kubernetes. We allow to provision persistent volumes, create load balancer services, and of course, cluster autoscaler. That's actually it. I want to share that last week we just get joined to CNCF Sandbox. So we are a pure open source project, and we are happy to share this news with you. A few links which might be interesting to you. First, a link of our community website, link to Talos Linux, link to Piraeus data store, actually docs, which allows you to run Piraeus on top of Talos Linux. And they're described how to configure it proper way. And also a few articles on kubernetes.io, where I spoke about how we built all of this system. And again, you can see all my other speeches and contact using this link. That's actually it. Thank you. And I'm ready to answer your questions.
We do have a quick comment from YouTube. There's no questions from this person, but they said it was super interesting and thank you for sharing.
Thank you for listening. If you're interested to know more about the parts and how the cluster API works, you can use this link and you can see that there is KCD conference. There is description for all of the components we use in Cozystack.
Awesome, awesome. I think that's it for now. And if any questions come up later, you can ask them in the YouTube comments. We will be re-uploading the live stream. Oh, just kidding. Right before we move on, we have a couple popping in here to the chat. So Andrei, stay on deck there. Brian Grant asked in the Zoom chat, not sure if I missed it, but does it integrated with a CI/CD model so that it can be managed as code?
Yes, so we use Fluxity, not the standard way. The main idea that we use Fluxity more likely like interface or Helm operator for delivering, for creating our API actually. So every application in our platform is just Helm release, but they have nice API on top of it. And Fluxity is responsible for delivering these styles to the Kubernetes itself. This can be simply integrated with any CI/CD. The main idea which we wanted to achieve is that every application can be run with just single YAML file. You want Kubernetes cluster, put YAML into Kubernetes and get Kubernetes cluster. You want Postgres cluster, you just put YAML and you create Postgres cluster, something like this. So it can be simply integrated with Argo CD or other Fluxity instances, or GitLab as well.
Awesome. Thank you, Andrei. And it looks like Brian loved that answer as well. We have another one in the chat here from Sergey said, can you describe how namespaces are implemented?
All right, I have it in a different presentation. Not sure if I will quickly find it. But actually we have this, we try to achieve a hard multi-tenancy model. That means that multiple users can be working with platform, not knowing about each other and not affecting each other. We consume Kubernetes namespaces for running applications, but we not let users to run anything, any of their workloads right in management cluster. So they forced to create new virtual machine or order tenant Kubernetes cluster and deploy it in it. But inside of it, they have full privileges, so they can install CRDs and don't affect management cluster.
Awesome. And one more comment from Brian Grant in the chat. He said he loved how you had an icon with turtles on the Kubernetes icon since you are doing cube on cube.
Yeah, I really like this subject. I use it for many years and I was doing that for a long time. At Vedas, I was doing Helm chart, which deploys Kubernetes control plane, but now I just found that guys from Classics get inspired by this idea and they develop operator for Kubernetes, for running Kubernetes in Kubernetes. And when you have API, you can join any node to them. So you have just KubeVirt virtual machines running in the same cluster, and they use standard kubeadmin join command for joining, and you can also try joining external commands. Unfortunately, right now we don't support this in Cozystack yet.
Awesome. Thank you, Andrei. I think that is all for the questions. But as I said before, and I'll say it again, please put any comments in the YouTube chat or the YouTube comments when we re-upload this in a couple of days from now. So thank you so much, Andrei, for sharing.